How do adversarial attacks fully CNN? Imagine trying to trick a machine that sees images just like us. It might seem simple, but these machines can be fooled in ways that are almost invisible to the human. Today, we're going to uncover how adversarial attacks manage to confuse convolutional neural networks. These networks are the core of many image classification systems. They analyze pictures by breaking them down into layers of features. The early layers spot edges and textures, while deeper layers recognize complex shapes and objects. The network builds an internal map called a feature space, which helps it decide what the image is. Now, adversarial attacks come into play by carefully changing the image in tiny ways. These changes are so small that we don't notice them, but they are precisely calculated to shift the image's position within the network's feature space. Think of it like nudging a puzzle piece just enough so it fits into a different spot. This shift tricks the network into thinking the image is something else entirely. The attack manipulates the internal features that the network uses to recognize patterns. It can even push the features toward a specific wrong class, no matter what the original image was. The clever part is that these perturbations are minimal. They don't alter the image enough for us to see, but they are enough to cause a big change in what the CNN predicts. Attackers often use methods like the fast gradient sign method, which calculates the smallest change needed to make the network misclassify the image. More advanced attacks can refine these changes further, making them more effective. In real-world situations like self-driving cars or security systems, these attacks can be dangerous. For example, a stop sign could be altered just enough to be read as a speed limit sign. This highlights the importance of understanding how these tricks work. Researchers are working on defenses like training models with both normal and adversarial images to make them more resilient. While tools like ChatGPT, DALL-E, and Midjourney are not based on convolutional neural networks for image classification, the idea of adversarial attacks reminds us that all AI systems need safeguards. If malicious inputs are used to manipulate outputs, it can lead to unexpected or harmful results. That's why ongoing research and ethical practices are essential in AI development. In essence, adversarial attacks fool convolutional neural networks by subtly changing images to manipulate how the network perceives them. These tiny tweaks exploit the way the network internally represents images, causing it to misclassify without any obvious signs of tampering. This shows us how important it is to keep improving AI security and reliability.